Hello students, today's point of discussion is preparation and physical properties of diazonium salt. Now diazonium salt is very important class of hydrocarbons. I mean diazonium salts are used as a raw material in the preparation of number of aromatic hydrocarbons. I mean it is very difficult to introduce any functional group to the benzene ring, but one can do the same quite easily by using these diazonium salts. Now remember, diazonium salts are the compounds which can be represented as Ar into X. So they are represented as Ar into X, where X can be chlorine, bromine, or sometimes BF4 minus, then SO3H, etc. So variety of diazonium salts can be prepared, but remember benzene diazonium chloride is most popular, and benzene diazonium chloride has commercial importance as well. Now let's see the nomenclature of these diazonium salts. So one thing to be remembered is diazonium salts are written according to the name of the parent hydrocarbon. I mean after the name of parent hydrocarbon we need to use word diazonium followed by the name of the anion. For example, consider this diazonium salt. So this is the diazonium salt and its name is benzene diazonium chloride. Benzene diazonium chloride. Another important diazonium salt which can be mentioned is, this is another diazonium salt and name of this is benzene diazonium fluoroborate. Benzene diazonium fluoroborate. So likewise, so in this way one can give the names to the diazonium salts. Now very important thing, the method of preparation. Now we are quite interested in preparing benzene diazonium chloride. So let's see the preparation of benzene diazonium chloride. So it is very important diazonium salt. So benzene diazonium chloride is prepared very easily starting from aniline. I mean aniline is needed to be subjected for the diazotization, and as a result of which we may receive benzene diazonium chloride. So take aniline which happens to be aromatic primary amine. When aniline is treated with mixture of NaNO2 and HCl in cold, I mean at about 273 to 278 Kelvin, then diazotization of this aniline takes place, as a result of which benzene diazonium chloride is obtained along with NaCl and water. So this is our product, benzene diazonium chloride. So in this way benzene diazonium chloride can be produced or prepared. So this is very popular method to prepare benzene diazonium chloride. Now let's discuss the mechanism of this reaction. Remember, mechanism is so simple and interesting as well. Look what happens exactly. NaNO2 and HCl react with each other producing nitrous acid. What we can express like this, HNO2, which can be given as. So first of all, what happens? HCl protonates this nitrous acid. Look, chlorine is more electronegative than hydrogen, so shared pair get attracted like this, and this hydrogen in the form of proton attacks easily on oxygen, and oxygen receives that incoming proton as it has lone pair. Thus the newly formed species will be like this. Now this oxygen bears positive. Now at very next stage, what happens? Oxygen hold this electron pair being electronegative, and in order to neutralize the charge accumulated on it, so it attracts this pair towards itself, and thereby departure of water takes place, and at this point chloride ion attacks on the electron deficient nitrogen. So this may lead to the formation of species like this. Now this is very crucial. So exactly what happens in very next step, our aniline. Now remember, in aniline, amino group is directly attached to the benzene ring, and nitrogen has lone pair of electrons. Now this species, which can be given as, it is attacked. How? We know very well that oxygen is more electronegative than nitrogen, so shared pair get attracted like this, and this nitrogen is now ready to accept the nucleophilic attack. So the aniline, with the help of lone pair on nitrogen, attacks on nitrogen of this species, and this may lead to the formation of a species that can be given in this manner. So this is the species to be obtained. Now nitrogen bears positive. So ultimate thing is what? Now there is attraction of electron pair of this bond towards nitrogen, as nitrogen bears positive, and secondly nitrogen is more electronegative than hydrogen as well. So this pair of electron get attracted towards nitrogen, and thereby departure of hydrogen in the form of proton takes place. Meanwhile, what happens? This chlorine holds electron pair of this bond towards itself, and thereby departure of chlorine in the form of chloride ion takes place, and this electron pair gets shared like this. So that lead to what? Departure of hydrogen in the form of proton, and departure of chlorine in the form of chloride ion, and leading to the formation of a species that can be given as. So this is the species so obtained, and remember this is a nitrosoamine. Now at this point, what happens? This nitrosoamine undergo tautomerism. I mean it tautomerizes, tautomerism. So look what happens. Nitrogen, by attracting this pair, shares like this. Oxygen is more electronegative, so electron pair gets shifted like that, and this hydrogen gets shifted in this way, and that lead to the formation of a species that can be given as. So this is the species so obtained. So this is a diazohydroxide. So this species is a diazohydroxide. Now at this point, what happens? This diazohydroxide get protonated, and oxygen receives the proton with the help of the lone pair. Thus newly formed intermediate species which can be given in this manner. So this is the species to be obtained on protonation. Now oxygen bears positive as it received what? Proton. Now at this point, what happens? Oxygen attracts this electron pair, and thereby departure of water takes place, and hence this nitrogen bears positive charge. So newly formed species which can be drawn as. So this is the species so obtained. Now this has another thing, this lone pair gets shared like this, and that lead to the formation of a species which may be given as. So now this nitrogen bears positive, and remember, rather than this is more stabilized due to presence of the ring. Now this is our benzene diazonium ion. Now this benzene diazonium ion ultimately combine with halide ion or anion, whatever present in the assembly, and that lead to the formation of a diazonium salt. So this is the simple mechanism which can be suggested for the preparation of benzene diazonium chloride by diazotization reaction. Now as far as physical properties of benzene diazonium chloride is concerned, now let's discuss some of the physical properties of benzene diazonium chloride. So very first property to be noted is it is colorless crystalline solid. Remember, it is colorless crystalline solid. As far as solubility of benzene diazonium chloride is concerned, it is found to be fairly soluble in water but less soluble in alcohol. Remember, it is fairly soluble in water but less soluble in alcohol. Another very important thing is it is less stable. So it is less stable, and in dry state it explodes. It is very important. In dry state it explodes. Thus it is always used in solution state. Thus it is always used in solution state. This is very important thing. Another very important thing is its aqueous solution is neutral. I mean, it has no action on litmus. Remember, its aqueous solution is neutral to litmus, but that aqueous solution conduct electricity. But solution, I mean aqueous solution conducts electricity, and it is due to the presence of the ions in that solution. And remember, electrical conductivity of any solution depends on the number of ions present in that solution. In fact, it is directly proportional. And the diazonium salts undergo dissociation when dissolved in water. The solution contain ions in it, and hence that aqueous solution is found to be good conductor of electricity. Thank you very much.